Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Faris Haman bin Johari, and today I will be presenting my final year project's proposal titled Impact of Barrier Sea Wave Towards V-Shaped Structure. So this project is under the supervision of Dr. Shaharuddin Ahmad. So in this modern era, a lot of high-speed vessel or high-speed craft that has been introduced to us throughout the whole world. So each of these vessels and craft has different performance. So to have a high-speed vessel or high-speed craft, this craft requires good resistance and seakeeping performance. So there are the major parts of this vessel that influence this performance is its hull. So there are many types of hull nowadays. Each of these hull has different performance depending on the design of the hull itself. So fast craft or vessel usually have a hull design that is shaped of a V. So moving on to the problem statement, like I said earlier, high-speed craft require good resistance and seakeeping performance. So hard chine hull is actually a V-shaped hull that usually used in designing these high-speed craft. So in this project, we intended to increase the speed of the speedcraft. So how do we increase the speed of this speedcraft is actually to improve the design of the hull by minimizing more resistance and making sure it have better seakeeping performance than before. So the objective of this project is first off is to analyze the performance of the V-shaped hull towards the sea wave, and through that analyzation the data will be collected to be used in improving the design of the V-shaped hull. So there are a few information and data has been collected through literature review. So there are 3 points that has been focused. So the first one is the importance of the ship hull design, and the second one is the characteristic of a quality hull structure design, and the third one is the criteria in designing a ship hull. So let's move on to the first point, importance of a ship hull design. So nowadays, boat manufacturers face a problem with their boat where the boat or their vessels use high amount of fuel. So this problem has led to another problem, which is increasing in carbon dioxide emission. So if we were to improve the design of the hull by minimizing the resistance, it actually helps reduce in fuel consumption. So with the fuel consumption has been reduced, it will automatically reduce the carbon dioxide emission. So as you can see here, by improving the hull design, not only it increases the speed of the vessel, it also helps in reducing the fuel consumption and reduce the carbon dioxide emission. So the second point is the characteristic of a quality hull structure design. A quality hull structure design should have 3 elements in them. So these 3 elements are high reliability, good performance, and easy maintenance. So these 3 elements should be observed by the user's point of view. Why the user's point of view? Because users are the one that is going to use the craft or the boat or the vessel. So lastly is criteria in designing a ship hull. So to design the best possible ship hull, 4 criteria that should be considered. So those 4 criteria are resistance, seakeeping performance, maneuvering capabilities, and lastly construction cost. So if these 4 criteria has been considered, there is a possibility that the ship hull that is designed is the best possible design. On to the scope and limitation of this project. So the scope here, the scope of this project is, first off, will be focused on the hard-shine hull. So, and then the simulation will be done towards the hard-shine hull to observe its seakeeping performance. So, through the simulation, we'll be collecting results or data, and that data will be used to improve the design of the hull. So the limitation of this project is that the simulation software that is going to be used. So the simulation software actually requires license that can only be used up until 1 month. So this have limit our time in properly simulating our hull. So second one is the specification of the boat. So the specification of the boat is not readily available. The specification must be found through previous research. So moving on to the methodology of this project. So we will be starting from the literature review. So in this literature review, we'll be gathering informations or data that is required for this project through previous articles or journals that is related to our project. So after information or data has been gathered, we will be moving on to the parameter selections. So parameter selections is where we select the parameter of the boat, such as the length of the boat, the breadth of the boat, or the draft of the boat. Not only that, we will be selecting the proper boundary condition also that is needed to be input in the software simulation. In the simulation of software, sorry. So after the parameter selection, we'll be move on to design of the hull module. In the design of hull module, we'll be using two types of software. So the first software is FreeShip software. So the FreeShip software is where the hull model will be designed. So after the hull model has been designed, it will be transferred to the second software, which is SolidWorks. So in SolidWorks, the hull will be converted into a solid model before it can be simulated in a CFAM software. So after the design of the hull, we go to selection of boundary condition. So the selection of boundary condition will be set in the simulation software or the CFAM software. So the boundary condition that will be set up are such as the mass of the boat, the area of the sea, the depth of the sea, and so on and so forth. So after the boundary condition has been set up, the simulation will be run. So if the simulation came out with inaccurate result or the parameter is wrong, we'll be recheck back our parameter selection to see if there's any wrongs or incorrect parameters. So from there we'll be start back to follow the flow of the methodology until we get the accurate result. So if the accurate result has been obtained, the data will be collected for the use of improving the hull design. So moving on, the expected result, there are 5 data that will be collected through the simulation software. So those 5 data are total elevation, scattered wave, incident wave, dynamic pressure, and lastly velocity. So as the picture shows in this slideshow is only a preliminary results. It is not the proper result yet. There are some errors during running the software, probably due to incorrect input of data. So in this part, I will be explain to you what is these 5 datas are. So we start from the total elevation. So the total elevation is actually the height between the peak of the wave to the trough of the wave. So the second one is scattered wave. The scattered wave is wave that is formed at the surface of the sea due to the collision between the boat and the surface of the sea. So the third one is incident wave. Incident wave is the vertical height between the peak of the wave to the surface of the sea. So the dynamic pressure is the pressure experienced by the boat due to the motion of the sea itself. So finally is the velocity. So velocity here is actually not the velocity of the boat, but it's the velocity of the surface of the sea. So it's not quite clear in this picture, but the velocity here indicated as a blue arrow around the surface of the sea. So that is for the expected result. So in conclusion, hull is actually an important part to be considered in designing a vessel. So by improving the hull design, where we minimize the resistance and improve the seakeeping performance, it really helps in improving the speed of the vessel. So that is all for my proposal for my final year project. So if any questions, you can contact me through email, or you can contact me through my WhatsApp number that is shown in this slide. So that is all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.